We can start 2 minutes early. Okay, the one on the outside the class, can you hear me? Okay. So do you have any question of what we have covered so far before we start the new lecture? Anyone have a question? Okay, no question. So today we will learn what is called program control, which is in your lecture note, I think, chapter number 5. We skip chapter 3, which is how to declare that variable and that the movement. But I'm covering that one in almost every lecture, because every lecture we need to declare variable and we need to use the move instruction. If you look at the program we have wrote so far, almost 70% of the command are the move instruction. So the previous lecture we learned how to do I/O, input-output, using DOS function. We learned DOS function 1, 10 for input, 6 and 9 for output. But actually one of the programs we have used yesterday, I told you I make a loop, and as a for next loop, isn't it? And you don't know how is that. I did that one to show you how you can use DOS function 6 to print a long string. So today we will learn how we do what we call program control. Program control, basically how we use if and how we use loop. But before that, I'm going to cover flowchart. Previously, I just write the code straight away. That is not a good idea. Whenever you want to do program, you must design your program first before you start actually writing your code. There are many design tools. I don't know if Dr. Chung have introduced you to any of them. Did you learn, what did you learn with Dr. Chung? Data structure? You learn software engineering. Okay. So software engineering, you should have covered what we call the program life cycle, isn't it? You remember program life cycle? Yes or no? Yes. In the program life cycle, you have design, then you have user requirement, then you have design, and then you have coding, and then you have testing. So design always comes before coding. So there are many design tools. You can use a flowchart, you can use a pseudocode, you can use what is called UML, Universal Modeling Language. Okay, you can use data flow diagram. Unfortunately, that one beyond the scope of my lecture. And assembly language is quite old, and therefore is very closely related to flowchart. Flowchart also is very old. So flowchart show you the logic. Flowchart is machine independent, is programming language independent. It shows you the logic. Actually, you can use a flowchart not only for programming, for any process. Sometimes you can see when you are going to registration, they give you flowchart for registration. So flowchart can be used for any process. Okay? So flowchart have symbol, and actually you don't have to buy a tool for flowchart. If you are using Microsoft Word or Microsoft PowerPoint, you will find the flowchart symbol are there. So there are many flowchart symbols. I'm not going to go through all of them. These are the one we use most of the time. I mean the common one. We start with this symbol called a terminator. Normally it have either start or end. Start is the beginning of your program, end is the end of your program. You should have only one start, one end. No more, no less. Any question? The start will have an arrow going out of it, while the end have an arrow going into it. And then we have what we call input-output, I/O, which is a parallelogram. So whenever you want to use input or output, you use this one. Okay? Then we have process. Process is basically any calculation. Okay? Even declaring variable is a process because you are putting a value in a variable. Okay? Then you have this one, is called the predefined process. We call it procedure, or some programming language, they call it function or subroutine. So basically, it's just predefined set of instruction. It's exactly like a process, but it have another line. So if you have a process, you must have a separate flowchart for the process. And then we have decision. Decision is whenever you actually do a branching. Otherwise, the arrow always go one way. If you want to branch, you have to make decision. For example, you are driving on the road and you arrive at a junction which have one goes right, one goes left. So you must decide which way you want to go, left or right, isn't it? So this is what we call decision. In a programming language, decision always is a binary, yes or no. So you'll have only two outputs. So the decision is the only one which have one arrow going into it and two arrows going out of it. Okay? Always two arrows, no more than two arrows. Then we have connector. Well, connector and off-page connector are used to make your flowchart not very messy. For example, if I have a flow chart, I don't want the arrow to cross. Okay, so what I do, I can use a connector. I will show you how to use all this one. From this lecture onward, before I write the code, I will write the flow chart. Okay? Then we will use the flow chart as a guide. Off-page connector is exactly like connector, but it's used for when your flow chart is too big to fit on a single page. So you use the off-page connector to connect the flow chart from one page to the next. Is that clear? Any question on flow chart? No. Okay. So the first thing we will learn today, any program actually can be made of these three constructs or three building blocks. So if you want to write a program, regardless of how big is it, you can write it out of three blocks. The first block is called sequence, which is what we have been doing so far. What do we mean by sequence? Sequence means the first instruction is executed, then the next one, then the next one, then the next one. There is no, what we call it, different path. There is no if statement, or loop. So like if you are writing a recipe, it says step 1, do this, step 2, step 3, step 4, step 5. There is no if the water is hot, then do something else, do something. There isn't. The next one we call selection. Selection basically is an if. So you write something if the water is boiling, then off the gas. Okay, so you must check, is the water is boiling? If yes, then you off the gas. Otherwise, you do nothing. Then there is iteration. Iteration is loop, which, for example, I can ask you if I want to give you punishment, like what you used to get in primary school, right? I love you a mess 100 times on the board. So this is a loop, is a for next loop. Okay? Is that clear? Okay. So we have done. So let me show you how they look like in the flow chart. So this is a flow chart for a sequence. You can see they go one after another. Okay? If deduction equal EPF plus income tax net equal gross minus deduction. So you do this one, then you do this. Okay? Now, selection, there are two. One is the if, one is the case. Assembly language does not have a case. Okay? It only have the if. Actually, it doesn't even have the if statement. It has something which you can use to make if statement. Very few programming languages have the case. But even if you don't have the case, I can make the case using what is called nested if. Okay? Nested if means one if, then inside it you can get another if, and then another if, and another if. So this becomes exactly the same logic as the case. So the if statement in high-level language have this form. If condition is true, then you execute true action, else you execute false action. This is called if then else. But there is another form of it, which is called if then, which have no force action. Okay? Sometimes you don't have force action. So if you don't have force action, just if the condition is true, then I do the true action. So what happens if the condition is false? You just go to the next instruction. Okay? So how it look like in flowchart? Look like this. So notice the if the decision, huh? One arrow going to it, two arrow going out of it. And you must label this arrow. You can put true and false, or you can put yes or no. So if the decision is true, I execute this one, and then that's it. I go to the next instruction. If it is false, I execute this one, and then I go after it. So these two will never be executed together, only one of them. While this one, the same, except there's no force action. So you can see if there's no force action, it just go down. So I just remove this one. Okay, any question? I just checked, there was no one requesting. Get that? I don't. I don't see anyone requesting. Okay. So, any question? Yes.
If then else, after executing either true or false, was it always purge one?
Yes. Because they will go to the next instruction. Is it possible that you mean here they merge here? I mean here true action and false action. I put only one what you call it action, huh? Not necessarily one action. It can have many actions. Understood? And this one also can be many actions. Not necessarily this one and this one are the same number of instructions. But at the end, they must, okay, go back to continue the flow chart. Hmm? Yes, I have here the request. I don't see anyone. I only have 15, unless they are not doing prop. I don't know. I cannot see any. Let's see any. I don't see anyone sending. Ask them to send. Oh, they can. Unless they are doing the not the correct one. I don't see anyone requesting. Who is the one requesting? Huh? I don't see him here. Now I can see. It could be that it is slow. The internet is slow here, so to give me the. Okay. Any question on how we do it in the flow chart? No? Okay. So we will learn how we do it, how we will do this one. Okay? Once we finish talking about the theory, I will show you how we do it in practice. Okay, the case basically is nested if. You can see is nested if. So condition one, if the condition one is true, I do this one. If not, I check condition two. If it's true, I do this one. If it's not, I check number three, and so on. And finally, you have what you call otherwise. This one is not compulsory, the otherwise. Then we have what we call iteration. Iteration, basically, there are two types of loop. One we call the while loop, and one we call the repeat until loop. You may say, where is the for next loop? Okay? For next loop, is either of these can be actually made as a for next loop. Either of these. The only difference between while loop and for next loop, basically, when you write the loop, you already know exactly how many times it's going to be executed. But while loop, we don't know. For next, we don't know. We can make what we call an input. So it can be external. So the difference between these two is basically where the condition to exit the loop is placed. In the while loop, the condition is put at the beginning of the loop. While for the while loop, the repeat until loop is put at the bottom. So what this will do is that the for next loop, the while loop may execute 0 time. For example, I can say while not end of file. I don't know how big the file is. So if the file is empty, straight away the loop will terminate because it is the end of the file. So this will never be executed. While this one, if I put, let's say, read something from the file and I put until the end of the file, I have a problem. What happens if the file is empty? When you try to read from it, you will get error. Okay? So normally, the while loop can be executed 0 time. So you will use it when is it possible that the loop can be executed 0 time, while repeat loop is used when the loop should be executed at least 1 time. So for example, if I want to have a menu, one do this, two do, and at the end you have exit, then I need to use repeat until loop because I need to display the menu first. And then if you select exit, you get out. If you don't select exit, then it will do the body of the loop and display it again. Okay? Any question? How we do loop? Any question? So program control only this. Selection, sequence, selection, and iteration. Now, how we do it in assembly language? Assembly language, unfortunately, it has no command for if, have no command for while, have no command for repeat until. So what it has this command, the jump. So jump basically, remember when we study about assembly language, you learn we have what we can use a label. So label will be used for program control and is normally used with the jump command. Now there are two types of jump, conditional and unconditional. Unconditional jump is called jump, JMP, and this is the syntax for it. JMP, then short, near, or far. Short, near, or far are what we call them option, not necessary to type them. You can type them, but not necessary. However, if you type them, they change how the jump behaves. Then you have label. Label is label, you write it in your code. Like start, remember? And yesterday we have start, we have next, we use them. So these are labels. So what's the difference between jump, short, near, and far? Basically, the difference between them is how many bytes between the command jump and the label. Okay? Which means how far the label can be from the jump command. The jump short, it means the label should be within plus minus 127 bytes. So if it is before it, it is minus 1 to 8. If it is after it, maximum 127. If it is further than that, you will get what is called runtime error. You won't get syntax error until the program is assembled. Okay? The next one is near. Near, it means 32K, right? Is the default. So if you don't type anything, you just jump label, the default is near. Near, it can mean can jump 32K forward or backward. And since your code segment is only 64K, therefore, if you are in the middle, you can jump anywhere within the segment. Far, if you are using multiple code segments, remember there are certain models which allow you multiple code segments. So if I want to jump to another code segment, then I have to use jump far. But in our case here, we only use small, so we'll always use the default, which is near. We don't have to write anything. We just type jump and the label. The next one is called conditional jump. And this will answer one of the few, I don't know who answered, who asked me at the beginning when I talk about the flag. I said there are 6 flags, which we call them status flag. And I told you we can check their status, isn't it? And you ask me how. Now you see how. Using the conditional jump. So the conditional jump will check the flag and it will decide to jump or not. The unconditional jump, no, there's no condition, huh? Once the microprocessor receives that instruction, he will execute it. While the conditional jump, no, it will only jump based on the status of the flag. Which flag? Depending on which jump command you use. And if you look here, the flag are the carry, sign, zero, parity, overflow. Which are the status flag? Now, since your number can be signed and or unsigned, you have different command. So this is the command, this one here, for unsigned number. Okay? So you can see how many commands you have to remember. You have to remember all these ones. You don't have to remember them. You can go to the microprocessor instruction set. Okay? So jump above, it will check the carry flag or the zero flag. We have jump above or equal, we should only check the carry flag. Jump below, it will check the carry flag. Jump below or equal, it check both the carry flag and the zero flag. So you don't need to remember which flag it checked. All what you remember is jump above will jump if the number is above certain value or above a certain another number. So this one for unsigned and this one for signed. Now remember, the microprocessor does not know your number is signed or unsigned. You have to remember. So if you want to treat your number as unsigned, use a set of commands for unsigned. If you treat it as signed, use a set of commands for signed. If you use the wrong command, you will get absolutely no syntax error. However, your program will not work as intended. Okay? So we have 2 commands. One is called conditional, unconditional jump, which is only jump. And conditional jump, you have large number of them. Okay? Now, if you look at my flow chart here, I have a decision, isn't it? The jump command, they do not check a decision. Okay? The unconditional jump, it will just like go from here to here. The conditional jump will only check the status of the flag. It does not change the flag. Okay? So if I want to say if x greater than 5, the condition x greater than 5, where to put it? There's a command for that. And it's called compare. The compare instruction compare the destination with the source. It has two parameters. How it does actually is subtract, okay, the destination from the source and put it in the destination. Your destination could be a memory or a register, while the source could be a memory, a register, or a constant. Immediate value is a constant. Okay? So the compare basically is subtract the source from the destination. It does not put it in the destination. Actually, the result of the subtraction is not stored anywhere. However, the result is used just to set up the register, sorry, the flag. So the compare should be used before the conditional jump. So before you use a conditional jump, we always use compare. Okay. So I have a program here which I call it vote.asm. Okay? Suppose there's an election and previously only 21 years old and above can vote, isn't it? That's why my program was written long time when the age is more than 21, but you can change it. So we want to write a program which asks you enter your age, and then you type your age, and then we'll check if your age more than or equal 21, it will tell you congratulations, you are eligible to vote. If it is less than 21, it will tell you sorry, you are underage. Okay? So we look at the flow chart. Forget about the code first, we look at the flow chart. So this is the flow chart. So you can see it starts with the start, then it display enter your age. Unfortunately, you don't see enter your age because it is small, but you can, if you enlarge it, it will appear. So display enter your age, and then it says input age. And then it check, is age more than 21? Yes or no? If yes, it display congratulations, you are eligible to vote. If no, it displays sorry, you are underage. And then the program terminates. Okay? Any question? How we do the flow chart? Huh? You understand the flow chart? You understand the flow chart? Okay. Let's look at the code. This is the code. So if you look at the code, I call the program vote.asm. Then I start with model small, then stack 200 as before. In the data, I create one variable, db 1013. You don't need the 1013 actually. 1013 is the new line. Type your age, please, 0 to 99, and then the dollar sign. Then age db 4 duplicate question mark means your age maximum is 2 digit, because remember the enter key. Okay, so 3 is 2 plus 1, 2 digit plus the enter key, and 4 because I need 1 to store the how many digit actually you type. And yes message db1013, this one to display it on the next line. Congratulations, you're eligible to vote. And no message db1013, sorry, you are underage. And then my code, the code start, then the first 2 lines here, we set up the data segment. And then the next 3 lines here, to print the prompt. And then this 3 line here is to input your age. Okay? And why I need this one? Now, remember my age is 5 bytes. If I draw it for you, although this on the internet, let me do it with PowerPoint so everyone can see it. Okay, can you see the PowerPoint? Okay, remember how I declare my variable? I declared age db 3,4 duplicate question mark. Like this. That's how it's shown how I declared, isn't it? you can check your, okay? So what does this one means? It means I declare a variable called age. And the first byte here, it have 3 because of this one. After that, I have 4 bytes. That's you have 4 here. So you have 4 bytes, huh? 1, 2, 3, 4. So let's suppose I type this will be used for the length of, so this one is the length, which basically how many characters you type. This will be filled by the DOS function for you. And since I have your age can be 2 digits, so basically if I type 15, this will be 1 and here will be 5. And here will be the enter key. Okay, this is the enter key. Okay, so now if I want to use an index, if I want to use an index, this will become age 0, the first one. And this is age 1. And this is age 2. And this one age 3. And this one age 4. Okay? So now I need to copy this one to a register. Why I need to copy to a register? Because I can compare with the memory, but remember my age is declared with a byte, dB. Okay? So I can read only 1 or read the 5. I cannot read them both at the same time. So I need to copy them into AX. I need to copy them into my register. So my register is AX. Okay? So here I will have a H. The most significant bit is AH, and AL is the least significant bit. So 5 should go into AL, isn't it? Right? So AL, you should have it should have 5. 5 is age 3, isn't it? So AL should have age 3, while AH should have what? Huh? What should be in AH? 1, isn't it? So 1 is age 2, right? And that's what I did. And that's what I did. I use dx here. I use like this, but I can do it exactly like what I have done in PowerPoint. Okay? I can do it exactly like I did it in PowerPoint. Actually, I will change this one and do it exactly like what we did in PowerPoint. Okay? And then I have the compare. Notice I put 21 between quotation. Because if you don't put quotation, it take it as number 21. Remember, when you type from the keyboard, you are not typing a number. You are typing the ASCII code. Okay? Whatever you type from the keyboard, it will be the ASCII code. And that's why I need to use quotation. And notice here the conditional jump. Jump above or equal, yes. So if your age is more than 21, then I go here to yes. Okay? I go here. And yes, I said move dx offset yes message. If no, I said move dx offset no message. And here I use the jump. Jump to here. If I don't have jump here, after this one is executed, this will be executed. So whenever you use an if statement, you need always conditional jump and unconditional jump, always together. The display message will display whatever is in the X, and then end. Okay? So this is how we do if statement. Any question? Any question? No question? Okay. Now, let's do the program. Okay. So this is the code we have it last week. I mean on Tuesday. I think I have the program vote. Let's see if I have it. Okay, it's not there. Okay, no problem. We can do it by ourselves. I start like this, so you can do it with me, okay? So vote.asm. It's a mistake, huh? Forget the what? What did I forget? What did I forget? Semicolon. Okay? Okay. Then I'm going. So a program to check whether you are eligible to vote. You don't have to use the word prompt. I can use anything else, huh? I can use please type your age, or I can use how old are you? Okay. Then age DB34 duplicate. Okay. And then yes, mess DB1013. Congratulations. You are eligible to vote. No mess. Sorry, you are underage. Okay. Now dot code start move AX segment prompt. Move DS AX This is to set up data segment. DS register. Now we display from move AH9, move DX offset prompt, interrupt 21H. Now we read your age. Move AH10, move DX offset age, interrupt 21H. Now we copy age into AX. Okay, I will use it different than what in the lecture note. I will do it exactly what I did in PowerPoint, okay? So move AH, age 3. Okay, so this is most significant bit in AH. Move AL age 2. This is the least significant bit in AL. Okay. Check age more than. Okay, now we check eligibility to vote. Huh? Now you want 18 or 21? Huh? 18. So we compare AX 18. Okay. Is age more than or equal 18? Now jump above or equal. Yes. So yes. So we display yes, miss. Else, we move DX offset, no mess. So no display, no mess. Okay. And here we must jump over this one. Jump display. Okay. And here, yes message, move DX offset, yes mess. And here will be display. To display, you need DOS number 9. Move AH9, interrupt 21H. This will display the message. And then I need to terminate the program, dot exit, and I start with start and start. Okay. Does it work? Let's see. Will it vote? Okay, how old are you? Let me type 18. Says, congratulations, you are eligible to vote, isn't it? Okay, any question? Everyone managed to do it. You type 18, it will tell you you are eligible to vote, isn't it? You type 15, 15, it should tell you sorry, isn't it? Let's type 15. Still say congratulations, isn't it? Why? Huh? Should tell you. Let's see. Let's see what's the problem. Okay. Let's fix the problem. So let me run the code and see. So let's run. Says, how old are you? Let's type, we type 20. Says, sorry, you are underage, isn't it? So it's actually doing it tabalik, right? See, if I type 20, it says, sorry, you're underage, isn't it? Okay. Let's, if I type 10, also, sorry, you are underage. Interesting. Okay. So let's try again and type 18. 18, it works. 20 doesn't work, isn't it? Let's try again. 15 doesn't work. Right? Okay. Let's see where's the problem. Now, the best way to find where the problem is, I go to debug. So let's see how to find the problem. Okay, F8 twice to set up my data. I can go view and CPU. Okay. Why I'm still seeing my data segment? This should not display the data segment. Okay. Move AH9. Okay. Let's press F8. It should 9. AH. Move DX offset prompt. Interrupt 21. Move AH10. Move DX offset age. Interrupt 21. It should tell you how old are you, isn't it? So let me type 1, 5. Okay. Then you can see my 15 is there, isn't it? Right? Okay. So now move AH, age 3. So AH should have tabalik, you put it. Okay. Now AH should have the 1, isn't it? Let's say if 15 is 1, 5, isn't it? Right? So now you are getting AH3. So you can see AX becomes 35. 35 is the ASCII code for 5. Huh? And move AL2, you can see 35, 31. Actually, it should be 1, 5, not 5, 1. Okay? So that's why you have the problem. So let's quit and mean this one. This is supposed to be 2, and this is supposed to be 3. The other way around. Okay? If you remember my PowerPoint, they were like this. Okay? So let's run it again now. Okay, how old are you? Let's say 10. Say, sorry, you are underage. Correct? Okay. Run it again. Let's say type 20 is okay. We try again. 17, it should say you are underage. 18, it should say congratulations. Right? So now the program is working correctly, right? Let's see. Let's run it again. Let's type this time 8 years old. What you should get? If 8 years, what do you expect to get? Should be sorry, isn't it? You are 8 years old. Can you vote? Should tell you sorry, isn't it? But what it says here? What it says? Oh, okay. Let's run it again. Type 5, 5 years old. Five years old. You can vote. Okay? 5 years old, you can vote. Let's run it again. Now, how old are you? I type nothing. Just press the enter key. Okay, say sorry. Now let's run it again. Okay, how old are you? I type AB. AB. So what's the problem? So we have two problems. The first problem is that when you type a single digit number, it tells you you are, unless you type 1. 1, it should tell you sorry, huh? Only 1 year old, sorry. 2 years old, you can vote. Yes, you try. 2 years old can vote. Because 1 is less. Okay. After, you see, it's reading always 2 digits. Now, if you remember where is my PowerPoint? I did not save it. We always take 2 digits. First 2. But only type 1 digit. So the next digit after the whatever you have typed is the enter key. And remember, the enter key is 13 hexa. Okay? So how to fix it? There are 2 problems. That's the first problem. If you type single digit, okay? And the second problem is that it accepts anything, not only number, right? Right? So 2 problems. Now, if you look at my flow chart, I closed my. Let's look at the flow chart. My code follow exactly the flow chart. Okay? In the flow chart, after you input age, we only check if age is more than 21. We did not check if the age is a single digit. Now, in high-level language, you don't need that. If you write in C++, you don't need to check actually if age is two-digit because or single digit, because the way the compiler is designed. Okay? Here, you are declaring as a byte. So, and then in high-level language, you can declare the variable to be integer, isn't it? If you declare it as an integer, it will only accept number. It won't accept alphabet. In assembly language, the computer doesn't actually have, when you declare a variable, you don't specify the type. You only tell him how many bytes you want to reserve in memory. So it is up to you to check if it is integer or not, or if it's within the range or not. So if we want to fix it, I need to change my design. I need to change my flowchart. So how we do it? After the age here, I need to check if the age is single digit or two digit. And I need to check if it's valid or not. So I need to change the flow chart. Okay. So let's see how we do it. I can do it without the flow chart, but you won't learn it how it's done. So let's Although I have the flow chart, I need to redo it for you. Okay. So if you want to draw the flow chart, you start, the flow chart symbol are here. Actually, you can get them here. You can see here flow chart, isn't it? Can you see that? Not this. Okay. Haven't shared. Okay. Can you see the screen now? PowerPoint. So the flow chart symbol, you click here, you can see them. This is the flow chart. So this is actually written on it, Terminator. Can you see Terminator? So I can start. If you don't want whatever inside, okay, you can select fill and no fill. And then you want to type inside it, edit text, and you can put start. Okay. Now the next one is display. This is the display. And display. Okay, you can say, how old are you? And then after that, you have input age. And then we have the decision. Which is here. You can see flowchart decision. Is age greater than or equal 18? I have yes and no. So yes here. No is here. So here display. Congratulations. And here display, sorry. So this is the old program. And we have down here end. No arrow so far. I can make the arrow. There is the arrow. And this one goes here. And then this one goes here. And this one goes here. And then I have another arrow. It goes here. You cannot use the line. You have to use this guy here. So and then you must put an arrow for it. Okay? I can do it the other way around. Just I can flip it. Okay? Then you can do the line for the last one. So this is the flow chart we have. We have in your note, isn't it? Right? Okay. So we have two problems. The first problem, as I mentioned, if it's single digit, right? Let's solve that one. So if it's single digit, what does it mean? You can vote or not vote. Single digit means your maximum age is 9 years old, isn't it? Or you can type ABC, but we'll fix that one later on. So if it's single digit, you cannot vote, isn't it? So I need to put another if statement. Okay? So I will put another if statement here. So let me move all this one down. Excuse me. Okay, so I need another if statement, right? I'll just put it here. Okay, so I will put is length of age less than 2. It should be always 2, isn't it? Right? If it's less than 2, what do you do? I forgot to type here yes, no, huh? So here yes, and here no. So if it is less than 2, yes. Less than 2, it means 0 or 1. So what we do, we just go here. I just move this one here. So if it is less than 2, we just display sorry. If no, we check if it's above 18, huh? Okay. Now I need this arrow from here to here. Okay. So after we input the age, we check if the length of age is less than 2, we display sorry. If no, we check here. Okay? Is it clear? Okay. So let's see how we do it. We call it, I'm going to call it vote 2. So let's see how we do it here. Let me save this one and vote 2 first. Okay? Okay. So what I need to do, I can do it here. Okay? Check if age is single digit. Okay? So what I want to do, I move. Okay, I don't need to move. Compare age 1. Yes.
Are you still on the PowerPoint?
No. Oh, I haven't. Okay, I haven't shared with you the other one. Okay. Okay. Can you see the code now? Okay, so what I did is I typed this 2 line. Remember, age 1 is where the length is. And notice here, I put a number, not within quotation, huh? Because this will be actually a number. Okay? I'm going to put a label here. I can jump to it. Okay? I'm going to call it 1. So if the age, so compare age 1, 2, basically is age less than 2, is not the age, sorry, it's length. Age less than 2. Okay? If yes, jump below, less than 2, jump below 1. Display error, enormous. So if it will go here to where is no 1 here, okay? Then after it will put this one and then it will jump to display, which is here, and then it will go out. If not, it will do this and it will check. Okay? If it's more than 18, then it will come here. If not, it will do still this one. So let's see now. Does it work or not? So let's type 20. Sorry, I need to share with you my whole screen. So if I run, I type 20, it says congratulations, as before, isn't it? Now let's run it again. And I type 1 year old. Says sorry, isn't it? Let's run it again. And we used to type, 9, it gives us congratulations, isn't it? Now it says, sorry, you are underage. Okay? So we solved the problem of single digit. But we haven't solved the problem of AB, huh? Still can take AB, huh? Or W or anything. But now because W is single digit, so still can tell me sorry. Okay? But let's say if I type TR, which is 2 digit, it says congratulations. So now single digit will always tell you sorry. 2 digit, still accept alphabet. So I will stop here. I will leave the one to fix the acceptance of non-character to you. That will be your innovation. I can tell you how to do it. You check if it is lower than 30H, which means 0, or above 39H, which is 9. Therefore, it is non-character. Okay. Now let's take the kehadiran. So it seems like I am having problem with your OBE system. Can I get the kehadiran?
How many years? One, only four.
Okay, now it managed to get it.
And then go out. Ada sehingga tertidur. Terbilang tengok. Anda.
Okay, you can scan. Okay, so that's all for today. I will see you next week. Remember, next week will be physical, huh? But make sure you bring your laptop with you, huh? Because we're still doing it like this, except the Kahadiran will be only done here. Because I don't have projector here yet. Don't forget, next week you will start having what you call short test. So make sure you are here on time or before time, huh? Okay, bye-bye.